Okay, so in Chapter 2, Section 4, we're now going to see some fractions that do not have a common denominator. And not only will we see them, but we need to be able to add them and subtract them, right? So we've got to use what we've learned in the last couple of sections, okay? Because what do you need when adding or subtracting fractions? Everyone, you need a common denominator, okay? So to add and subtract fractions with uncommon denominators, let's find the least common denominator. When we find the least common denominator, we keep the fractions as simple as we can. Rather than blowing them up into huge fractions, we try to keep them as small as possible, and yet we still need to have a common denominator for adding or subtracting, just like you did yesterday. And you guys did great yesterday with adding. When given common denominators, it's not too hard. We simply add what? Everyone say it? The numerators. Good. Okay, so we look at these two. You guys can't see. With 3/4 plus 1/3. So of course the biggest mistake would be what? Somebody does what? Brian? They just add them right now. What would happen if you added the top and the bottom? You would get 4/7. Do you think that answer would show up on a multiple choice test? Yes, because that would be the biggest mistake, right? So we never add denominators. So we've got to change these fractions so that they have like denominators. And what would the smallest multiple be? The least common multiple, both 4 and 3 could become when you multiply them. Olivia? 12, good. So these numbers are so small, you don't even need to go do any fancy factor trees and things. I mean, in your mind, you probably went 4 times 3 is 12, right? And they have no factors in common, so that works. So now we blow up these fractions. The first one, 3/4, what did we multiply the 4 by to get to 12, everyone? 3. So we will multiply the numerator by the same factor, 3. 3 times 3 is 9. And we multiplied the second fraction's denominator by 4. Good. So we're going to multiply the numerator also by 4 and get 4. So now we're right back to yesterday. Once we have fractions with like denominators, we simply add the numerator. So Jake, tell us what we have here. Can you add these for us? Good job. It says 13/12. And improper fractions are not usually considered simplified forms, so we want to change it up. Can you change it to a mixed number for us? 12 goes into 13, yeah? How many times does 12 go into 13? And you have a remainder of 1, which is still being divided by 12, right? 1 and 1/12. Good? Okay. So question B says 1/6 minus 3/8. So we need to think what denominator is the smallest multiple of these two numbers. You might make the list again. These are small numbers, right? So 8 times 1 is just 8, but 6 can't become 8, right? Easily. So 8 times 2 is 16. Again, 6 can't become that. And what do you think it is, Kimmy? 24. Good. So why don't you tell us, how did this first fraction's denominator become 24? 6
by 4.
Good, times 4. So the numerator becomes what?
4.
4. And then the second fraction, 8 times
3.
3. So the numerator would be
9.
good. Now, what strategy have I asked you to use when you see the subtraction? Do you remember, Cammie?
You change to a plus sign and make the number negative.
So add the opposite. So now we clearly see where the negative is. It's up there with the 9. The second fraction is a negative fraction. And we now have a positive 4 plus a negative 9. So will that sum be positive or negative?
Negative.
negative because the 9 is a bigger absolute value, right? And so the denominator will be, doesn't change. And what is 4 plus a negative 9? I think everyone knows this. What is it?
Five.
Is it possible to reduce this fraction? So these two numbers, 5 and 24, are relatively prime. So compared to each other, they have no factors in common. So everybody say relatively prime?
Relatively prime.
And you got it. Okay. And what are we going to do about C? C is interesting. It doesn't even look like a fraction minus a fraction. It looks like a whole number minus a fraction. So how can we handle this thing? Is it 2 over 1? Good job. Okay, so you can change any integer into a fraction by putting that denominator 1, right? And so now what would the LCD be for these two numbers here? Gavin?
5.
Good job. So we didn't even have to change the second fraction here. Love it when that happens. We only have to change the first fraction. And what do we multiply both the top and bottom by? What'd you say? You're thinking of the 2 times 5. Okay. And 2 times 5 is? 10. So we have 10, and it said minus, so I can write it that way. But really, we do want to change our subtraction. So Gavin, tell us how it will read when we do that. 10 fifths plus a negative 3 fifths. Okay. And I know that 10 minus 3 is a pretty easy thing to do, but we just use this strategy in case we get to those tough ones, okay? And so 10 minus 3 is 7 fifths, right? And now, Gavin, give us that in a mixed number.
1 and 2 fifths.
Good, 1 and 2 fifths. 5 goes into 7 once, and there's a remainder of 2. So 2 is still being divided by 5. Very good. Let's try it again. Do I have a volunteer? If you're at home, just pause, come back and see what we got. Okay, so we found the common denominator 36, blew up these fractions, and then simplified. Negative 1336. Okay. Oh, that's it. You may begin your work.